Hello friends, welcome back to our channel Demystify Frontend, and in this video we are going to demystify the internals of Redux, which is a state management tool. You must have used it in your applications. But before I start, let me give you an abstract idea about the Redux package, like what it is and what problem it solves for you. So if I take you back to all those applications where you have worked, and those were quite big application having big state, and you must have faced some issue while managing the state of the application, because if you don't have any standard approach to deal with the application state, you will end up with a messy state management in your application, and you will notice most of the bugs you encounter, they are related to the state poorly managed. So when your application is big, your state is also big, and it gets unpredictable. Like if you make a change in one part of the application, it will affect rest part of the application in an unpredictable way. So that's the time to look out for the solution like Redux, which helps you centralizing your state and keeping it immutable, and also let you update the state through a proper channel through the proper APIs which the store provides to you, like dispatch and all, and providing you the real updates happening within the store through any part of the application through a store subscription. So we will touch every nook and corner of the Redux store, and we will not just go through the core concepts theoretically, rather we will build the Redux store package through our bare hands, and we will look into each of the design decision made while designing this package. So let's start with the first core concept, and the first core concept that comes to my mind when I talk about Redux is reducers. So this is the place where you will manipulate your state, right, based on the actions you receive from rest part of the application. So let's understand what reducer function does and how it does. So reducer function takes two arguments. One is the current state of your application and another is the action, and it has its own recipe which will decide based on the action like how it is going to manipulate the state. So if you look at the code of this function reducer, we have a state variable here having this default value as 0, and so this is basically a sort of counter which based on the action either it will increment the counter or decrement the counter. Okay, and if we pass some action which is not identified by this reducer function, it will return the state as it is without applying any mutation to that. Okay, and I have some use cases here. I'll just go through each of them. So we call the reducer first. So initially we don't have any state, so I am passing undefined as our current state, and I pass this increment action. So action takes a shape of an object. So it's a convention in the Redux to pass the actions as an object and keep a property type in each of the actions, so that in within the reducer we can make assertions on the basis of action dot type property. So this reducer will return back the updated state s1 which I have logged out here, which is 1, and now this state becomes the current state of the system. So that's why you must notice on line number 17 the current state which I am passing to the reducer is s1, and the action again is increment. So now the reducer will make update on the existing state which is passed to the reducer. So now it increment the counter, and the counter value, that is s2, is 2, and we again call out the reducer with the current state s2 and we get back 3. Okay, so this is a, I guess this should give you a fair idea about like how the reducer function works. So basically it takes the state and action and return back the new state. Although we are not going to call out the reducer exclusively directly, rather we will call it through some API. So this will be called ultimately, but we will not call it Okay, so we will just call the dispatch method on the store, and that will eventually call this. So we will see that, okay, very soon. And there are few more things which you should know about the reducer. The first thing is reducer function should be a pure function. What do we mean by pure function? So pure function is nothing. This is a concept in functional programming, that a function is said to be pure when it only depends on its arguments and nothing outside the arguments. Means it doesn't read any global state variable or global variable which is defined outside the function, because doing this will make it impure, because the output of the reducer function will be unpredictable in that way, right? But if it is a pure function, if it depends only on the state and the action, or if it only depends on its arguments, then for a given set of input it will always give you the same set of outputs. Okay, if you find it difficult to understand what do I mean by purity, let me give you an example. So now you know how we got this s1 s2 s3 calculated, 1 2 3. Now let's say I define some variable here, let's say g, and I assign it 100, and now inside the reducer I am basically adding this g variable to the state. Okay, now you see the state of this reducer is changed to this 101 202 303, right? But now let's say I update this variable somewhere in the code to, let's say, 200. Now I'm passing the same argument here to the reducer, but the output is changed due to the this impurity that we have injected inside this reducer function. That is its dependency on the something which is defined outside the function. So that's why it is recommended to keep these functions pure, because if the reducer is pure it will be predictable, and our store state, the state which is kept inside the store, that will also be predictable. And that's why we call the redux as a predictable state management tool. Okay, so now this should be clear what is reducer and how it works. So now let's move on and let's add some complexity to our reducer function. So basically I'm trying to give you a sort of chronology, like how things would have been developed within the redux package. Okay, and all those decisions, all those utilities which redux provides. So let's move on. So I'll just comment it out and I'll add some complexity, because the state is not going to be very simple. We are going to do tons of things, right? And I'll just uncomment this piece of code. I have something for you here. Let me uncomment it out. Okay, now, yeah. So this is again my reducer function, but I have added more state variables and more actions. So it not only keep a counter, but it also keep a list of to-dos. Okay, so you can see in the console now the state is an object having some properties, count, to do. Okay, so now you can see we have added like some sort of complexity, and if I keep on adding more and more state variables and more actions, this function will grow exponentially, right? But this is not how we are going to write our reducer functions, because this approach will not scale very well. Rather we should write multiple reducers, and we can have some utility which can combine the state returned through each individual reducer function into the complete state, right? So that's what this combine reducer function provides to you. So combine reducer, let's split this function into multiple reducer first. So now what I do here, So instead of keeping everything inside a single reducer function, we have divided our reducer into slices, and we can call them sliced reducer. So each reducer function will contribute to a slice of the entire state, and together they will constitute a complete state, right? So the counter is the same, which only act on the count state variable, and we have to do, which will manipulate only the to do state, right? And we have imported our combine reducer. I'll just take you through that. And the combine reducer basically will take the object, and now this object is something where key represent the state and value represent the reducer function which will manipulate that state. Okay, so this combine reducer function will return us a single reducer function, right? So now we are calling the reducer function with undefined initially and that increment action. So what it will do, it will basically return back the entire state in the form of this object count and to do. And you see this increment action basically manipulated only the count property, right? Because it act this counter function reducer function will act only on the count property. And similarly in the last action we passed add to do action which manipulated the to do state prop, and you see the last state as 3 as we have the count as 2 and to do as 100. But how this combine reducer combine these reducer functions? So let's go to the combine reducer. So this is the combine reducer code. So what happens, it will accept a reducer map object. So what we do here, first we filter out like if we are passing something, anything, we are not passing the reducer as a function, so we will filter all those values out, and we will only keep the valid key value pairs from the reducers map object, and we can extract the keys of the object in final reducer keys, and we return a reducer function which accepts the state and the action. And now this is the reducer function which we will be calling to get our new state, right? So we can keep this empty object as the default state when we pass undefined initially to the reducer function, and it will calculate the next state. So what it will do, it will just iterate through the reducer map object which we pass to the combine reducer, and we will call out each of the reducer, and to each of the reducer function we will pass the current state. So we can read the key, so we can pass the current state to that reducer function and the action, and we can get back the next state which we can assign at the same key in our next state object, and this way we get back this next state calculated through this reducer function. Okay, so that's why, like, so combine reducer basically helps us combining it helps us keeping the reducer function manageable by dividing it into the slice reducer functions and combining them into a single reducer function. Okay, so let's get back to the main.js. Okay, so this is how the reducer works, this is how the combined reducer works, but we are not going to deal with the state directly, we are not going to mutate the state directly, rather, and we are not going to let the state update directly through any part of the application, otherwise it will defeat the purpose of Redux. So what Redux does, it basically keep the state in a sort of safe, right, so that it is not updated directly. So now let's create the store APIs which you are familiar with, like get state, dispatch, subscribe and all. Okay, so we are not going to update the state directly by calling out the reducer, but it is the responsibility of store to call out the reducer with the current state and provide us the updated state, right, through these APIs which we are going to develop now. So to create the store, we will define our function create store, which will accept the reducer function, and it will also accept another variable, that is preload state. So you can say this is the, we can seed our store with some initial state if we have any. Okay, and it will create a state variable. We can assign the preload state to it if we have any, otherwise it will be undefined. And this store will provide us some API, right? And one such API is dispatch, which takes the action, and another such API is going to be get state, which will return the current state of the store. And there is one more API. Okay, we will come to that later. So let's write the code for dispatch. So what the dispatch is doing, it will basically update the state by calling the reducer function. So to the reducer function, we will pass the current state, which is kept here in the state variable, and we will pass the action. And as you know, the reducer will return back the updated state, so that we can reassign the updated state back to the state variable. And whenever someone try to read out the new state through this get state method of the store, we will return back the updated state. So to make these APIs accessible, we should return an object, and we should place these methods on this object. Okay, so now let's see how it works. Or so basically I'll just comment out all these things, right? So now what we will do, we will create the instance of store first. So let's call the create store. I guess I have not exported it. Okay, so let's export this. Let's create store. Okay, so let's import it. So we should place the import statement at the top of the file. Okay, so yeah, don't worry for now. So this is just for demonstration. Okay, go to source and store. We have this method create store. All right, so we call the create store, and we don't have any initial state. We pass undefined. Okay, no, the first argument is going to be reducer, right? So we have our reducer function ready through this combine reducer, and to the preload state we are passing nothing. Okay, so next thing we will do is we will call that store. We will basically dispatch an action so that our state is updated. And what we are going to do, we are going to pass the increment action, and then we will see how is the state. So we will call the store dot get state method. Okay, so yeah, so we get back our state, and you see the count is incremented. Now if I do the same thing once again, let's say I increment it once again. Yeah, so you see this is the initial state after this increment dispatch, and after the second dispatch again we have updated our state. You see the count as 2. Now let's use some other action. Let's say add a to do, and we are passing the payload as 100. Oh great, you see another slice of the state is also getting updated based on this add to do action. So now you see how we devised our combined reducer function. We wrote the reducer functions as different slices which update different slices of the state, overall state. And through the store we call out the dispatch method, which will basically call out the reducer function to calculate the new state and update the state within the store. And how we read out the latest state of the store through this store.get state method. Now there is one more use case, that is reactivity within the store. Means we can subscribe to the state updates and we can get notified immediately whenever there is a change in the state, whenever there is a change in the state of the store. So for that we will implement one more function here, one more method by the name subscribe. Okay, so which takes a function basically. Okay, let's spell it correctly. This is subscribe. So store will basically keep the list of listeners. So currently it is empty, and what we will do, so if we can make a check here, if type of the function is equal to function, so it should be a function, right? Subscriber should be a function. If it is function, then we will basically push it into our listeners array, right? And whenever there is a dispatch call, once we calculate the state, we can go through the listeners array and we can call out each listener. Okay, so we won't pass the state because each listener can make a call to the get state. So this is how the Redux is written. And subscribe will also provide one function here which we can call to unsubscribe, right? So to unsubscribe it, we will have to keep the ID of the listener, and let's say listener ID. So when you push something in the array, it will give you the length of the array, which is the last index. Okay, we will update our listeners array here once this unsubscribe function is called. And what it will do, it will just simply splice the listener at this particular ID, right? As simple as that. Now go back to the, okay, we will have to expose this method as well, subscribe. Go back to main.js. Now let's say when we create the store, we also add one subscription to the store. Okay, and this is something, let's say subscriber. So instead of calling out like checking the state every time, we can make use of the subscriber to log the state, right? So inside the subscriber we can basically log the state. So just call the store dot get state and see if it is working. Yeah, fine. So now you see the state is logged through this subscriber log statement. Now let's say if you subscribe after the first dispatch, so you won't get the log from the first dispatch, but you will get from the last two because of the subscription time, right, which happened after the first dispatch. So this is a sort of reactivity, like you get the real-time updates on the store happening regarding the changes happening through any part of the application. So this is the very basic overview of the store. I hope you like it. I hope you get the crux of, get an abstract idea about how the machinery behind the Redux works. But there is more things, like we can write store enhancers which can enhance the behavior of the store. Like we can add the support for the middlewares also. So if you are finding it interesting, you can write in the comments. And if you want to write if you want me to create like more advanced topic on the Redux, which includes like how the middleware works, how the Redux thunk works, just write into the comments and I'll make a separate video on that. Till then, take care, goodbye, and happy learning.